In the previous video, with this same set of data, we're able to establish that we cannot use the paired samples t-test for this, even if our data is in ratio level, because we were not able to establish the fourth assumption before we could use the paired samples t-test, which is the normality of the distribution. In the previous video, as mentioned, we were able to establish the symmetrical shape of this, the differences between our data here, which allows us to use the Wilcoxon Signed-Rank Test, even if our data is actually ratio in level. So we have here the same number of branches for a certain fast food company. We have 1 to 100, and each of them recorded the following number of order service, let's say from 11 to 12, from day 1. And for day 2, after a certain change is implemented. So they would like to know if there is significant difference between the number of order service from day 1 and day 2. So for this, again, even if the data seems to be ratio and level, since the normality was not established, we are going to use here the Wilcoxon Signed-Rank Test, which is the non-parametric equivalent for paired samples t-test. Before we go to that, let us go here to our variable view and again say that our branch here, let's just say nominal in nature, because the data for branches 1 to 100 are just representations of which brand is it. The number has no specific order nor cannot be included in any additive property. Now, day 1 would be the number of service on day 1 is scale, okay, and then day 2 is also scale. Okay, because this is both ratio and interval, so we have scale there. So even if again they are both scale, we can use here, or we will be using here the Wilcoxon Signed-Rank Test because of the explanation given earlier. So before we go again to Wilcoxon Signed-Rank Test, here are some assumptions. The first assumption for a Wilcoxon Signed-Rank Test to be used is that our dependent variable, which is the number of orders service, is at least, again, think of the word at least, ordinal. So this data here are in ratio, so it still fits the assumption number 1 of at least ordinal. So that means assumption number 1 has been met. The second assumption is for our independent variable, the gathering of data in with a period of time, the day 1 and day 2, or the number of days. This should have matched, or this is a match pair. That would mean that for a specific branch, we have a data for day 1 and day 2 on the same branch, so that this would be a match pair. And you can see all of the 100 data here, or 100 branches, have recorded numbers of order service in 11 to 12 rush hour for day 1 and day 2 right after a change is implemented. And the third assumption that was covered in the previous video is actually telling us that the distribution is symmetrical in shape. And we have shown that already, that even if we cannot establish normality for the paired samples t-test, we have established symmetry in our distribution. In our previous video, which the link will be posted below, you might want to check that one to determine or to review the process of testing for symmetry. We have already established this assumption, and that would mean all of this assumption for Wilcoxon Signed-Rank Test is good. And let us now use the Wilcoxon Signed-Rank Test to test for the difference between a day 1 and day 2 number of orders serviced. Let us have this hypothesis before we could proceed with our test. Our first hypothesis, our null hypothesis, the hypothesis of no difference. Let's say, for example, it could be like this. There is no significant difference between the average number of orders serviced for 2 days after an implemented change. Or let's just say the day 1 and day 2 after an implemented change on the specific rush hour 11 to 12. Let's just pick rush hour so that we could, so that the data here, or the purpose of testing difference, will actually be beneficial for the said fast food company. Each sub A, or alternative hypothesis, states that there is a significant difference between the average numbers of order service for 2 days after an implemented change. So that I don't know if my structure is understandable, but it means day 1 and day 2. It should be like that. Okay, now let's look at our null hypothesis. That is the hypothesis we're testing. We are to reject that with this region of rejection. If we will get a p-value of less than 0.0005 rather, that would mean we reject our null hypothesis. And if we do, we could say that the difference between the average number of orders serviced from day 1 and day 2 after applying a certain change is significantly different. This will only be true if we will get a p-value of less than 0.05, which will reject our null hypothesis. Now that we have all of this, let us now start our Wilcoxon Signed-Rank Test for this specific data containing ratio level of measurement. Same process will be copied. Click Analyze, go to Non-Parametric Tests, hover to Legacy Dialogues, and you will see here 2 related samples. Because we have day 1 and day 2 in the same branch, they are related samples. Again, this is just Wilcoxon Signed-Rank Test is just the non-parametric equivalent of the paired samples t-test. Again, Analyze, we'll have non-parametric tests, Legacy Dialogues, 2 related samples, and you click that, you will have this dialog. If you would like to review the paired samples t-test dialog, it's almost similar to this, where you are to place your match pairs here. So you highlight both of them, you click this arrow. If you would like to return that, return, or again, do it again. Yeah. Now, take note that our Wilcoxon has already been checked here. And let's just visit options for descriptives, because we would like descriptives for a better explanation and interpretation later. Okay, so click check descriptive, click continue, and now you're ready to click OK. Once you click OK, you will see these results. You'll have 1, 2, and 3 tables. The first table is for your descriptive statistics, which includes the number of data or responses for day 1 and day 2. Again, they are match pairs, so they must have the same. And you would see here the number of orders serviced on all, or the mean for all 100 branches is 26.16 for the rush hour 11 to 12. Okay, you would see that there is an increase, slight increase for day 2 on the same 11 to 12 rush hour for the same 100 branches, 29.54. These were the number, the mean average number of order service for all 100 branches for day 2 after a change is implemented. You would see a difference, but is that difference significant? Because we cannot automatically say yes. That's what we're testing here. Go to our second table, our Wilcoxon Signed-Rank Test. The ranks here, negative ranks and positive ranks, going back to our data just for a little bit explanation, you are to actually look at the differences between day 1 and day 2. Some of us will just take day 1 minus day 2, so that would be negative 11 here. This would be positive 5, but no need to worry about which comes first, as long as you will start with day 1 all minus day 2 or day 2 all minus day 1. Our results will just be opposites. We will just be trying to record all of those differences rather, and we'll be ranking them. Once we rank them, we add all the ranks of those negative ranks, negative differences, and positive differences. And here comes the idea. The negative ranks would be the ranks of those negative differences. You have 37 of them. For positive, we have 59. You also have your explanation here. And you will have 4 ties for all 100. So these are for additional ranks for your Wilcoxon Signed-Rank Test. And here is our test statistic. The z-value is negative 3.521. This is actually to be subjected to a certain distribution table if we're solving for this manually. But since SPSS is already here, let's just proceed automatically to the significance value of 0.000. This is the significance value for our test. This is less than 0.05, which will tell us that we are now ready to reject our null hypothesis. The hypothesis stating that there is no significant difference between the means of the number of orders serviced from day 1 and day 2 after an implemented change. Okay, we reject that. That would mean there is now a significant difference. That would mean this difference here of, let's say, 3 point something is enough for us to say that the difference is significant. Okay, so if we are now ready to reject and state that there is significant difference because of this p-value, going back to our data here, we could say now that the differences after an implemented change is significant rather. And if you are the one or the owner of this fast food company and would like to know after an implemented change if there's significant difference with your implemented change, that would mean that implemented change actually, look at the value, increase, actually improved. Okay, significantly improved the number of orders serviced. So probably it would be for the number of what they call this one, crew staff. I don't know what changes that. Is that the number of the parking? I don't know. Again, we're just trying to look at it generally. So what are the possible changes that this fast food company has implemented to see this change? And that change has been proven to be significantly different. Take note again that we are using here the Wilcoxon Signed-Rank Test because we were not able to establish the normality of the distribution. That is actually an assumption for the paired samples t-test. We have used here the Wilcoxon Signed-Rank Test after identifying all assumptions together with the third assumption, the test for symmetry. See you in the next video.